They're counting. Oh, hey, we're back. Part 2.
Part 2, yeah. 5 floors up and 5 down. I'm back on the 3rd, and that's not a leak. That's a scheduled venting.
This is a fully scheduled venting event.
Venting the boiler. I mean, we are basically bleeding the boiler. Last night, there was a thought that we have some air pockets in the boiler when we did the hydro test. So this morning, somebody had an idea. Hey, let's bleed some water through the high points, and let's bleed that air out.
And you did that.
That's what they did.
So it's just like if you have an oil furnace or an oil burner, sometimes you got to prime it, you got to do that little thing, bleed it a little bit to make it start again so that you can keep the air out of the system, because air
Basically,
is bad.
we're keeping the air out of the system.
You don't want air in there.
No, it's not good. We are on the 3rd floor of the STG building, so that will give you a good look on the turbine and the generator.
So this is sort of place you can come, take a break, lean on the railing here.
What's STG mean?
Steam turbine generator building. STG building.
The steam turbine generator building.
Yeah.
So there's big labels, that's where steam is going.
Correct. So there's high pressure steam, low pressure steam, medium pressure steam.
And that looks like a jet engine.
That's an exhaust. Yeah.
So it's pushing
it's a turbine.
some.
Yes.
So the turbine is pushing some stuff out of here. And is this actually generating? What is this going to do?
That's the generator. Generate the power.
That is the generator.
Yes. There's a generator. There's a gearbox in the middle, and then you have a steam turbine.
So this is where it all comes together.
Right.
What's your favorite part of all?
Of course, it's a steam turbine. I'm not an electrical. I'm a mechanical engineer.
I like the thing that spins.
Yeah. And the water and electricity, they don't like each other.
No, they don't. They don't.
So where do we go here? So we're gonna go one level down. So this is our future control room. Those guys are working, checking the loops, and we don't want to interrupt them.
No, they're at work.
Correct. So that's where the magic push buttons.
Well, he's waving, come in.
Let's go. You want to talk to the guys?
Sure, let's go talk to the guys.
Come on here, man.
Hello.
Hello. How are you doing?
Doing well. You are live on Facebook right now.
Oh, God.
Yeah, it's exciting.
Wonderful.
Yeah.
I'm tickled.
I'm alive. Guys.
You got a lot of monitors here.
Don't let my
Got a lot of monitors. We're just not quite there yet.
No, it's you're
Yeah.
getting ready to turn things on.
Oh, y'all, we've had
They're trying
it. It's been going up here
They're making magic here, you know.
since I got here in May, and it's been booted up here since May. So, yeah. We just ain't got it all probably down there. It's got through tiny and everything, with the permanent installation on the power and the communication cables to the server room. And
So you got the sit to stand desk. Do you like to
yeah.
stand up when you work, or you like sitting down? Do you have a preference?
up all day long. It depends. I'll go up and down, up and down. That way, it's, you know, so.
Since they don't go
Very healthy, yeah.
Yeah, it keeps things fresh.
Yeah.
You got a lot of flashing red lights.
Well, that's just early on. I've seen more than that. I've seen 5,000 alarms early on a big project, you know. So we got what, 1,000?
It's going pretty smooth.
Yeah, actually it is. 1,000 alarms on a small plant like this. That's that big a deal.
Yeah, no big
No, it
deal.
really isn't. It really isn't. So I've been on big coal fires. I've seen 5,000 alarms early on. I mean, they've eventually worked themselves out, and make changes and different things get going. So a lot of stuff's not hooked up, generating bad quality alarms, but it all comes together.
Excellent. Thank you for letting us come in. And I like the magnifying glass. So is that just to help look at some plans and you did really
we
get in
talking
there?
about this?
Yeah, that's the.
Well,
This is
Look at me
this
and
is
me. Look
eBay's finest, buddy. That thing cost me almost $3.
here, look at him and look at me. We need a magnifying glass every once in a while.
Yeah, got to raise up those glasses so you can look real close in there.
Oh, dude.
Thank you. So it's you got to have sort of a nice temperament to make sure just everything keeps on flowing, not get too excitable. It's all under control. Humans can handle it. We're trained for this thing.
Yeah, we are professionals.
Maybe these guys down here. Look at these professionals. Hello.
Oh, Jeremy. Oh, I'll give you a call.
Hello. stuff in there. There's rooms all over the place. Oh, let's go right in here. We'll look at this stuff up close. So we were up there, a level above. That's where we were leaning over the railing while Peter gets some stuff sorted out over here. So this is what he described as the generator, AC/DC style, high voltage. I was just singing some AC/DC. All right, so we're down here. We were up there a couple of seconds ago.
Up there, and this is your generator. Let's go over here. So, just let's follow it as it was. So, coal goes to the boiler. We boil the water. We produce the steam. Now steam comes over here. 600-pound steam. It's from the other side. There's a piping on the other side. It comes to the turbine and spins the turbine basically.
Just round and round and
Just
round and round and round and
about-
round and round.
About, I don't remember. Is it 36 RPMs? 3,600 RPMs? I think that's what it is.
Fast.
Oh, pretty fast. Then you have a gearbox that changes the RPMs that goes to the generator, and generator produces the power, basically. That's how it goes.
So spin, 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 spin. Whoa, whoa, whoa. Rein it in. Bring it under something that we can control. Then it goes out there, and then in there, it suddenly is lightning. Harnessed.
More or less.
Harnessed lightning,
Yes.
so that I can charge my iPhone.
Yeah, you can plug it in, I guess. Somewhere here.
But I'm assuming this is also a place where there'd be lots of noise. The turbine's
Yeah,
going.
it's going to
is
be noisy.
really loud, thousands of rotations per minute.
3,600,
Yep.
more or less. But then the steam goes from 600 psi. The pressure keeps coming down. And at the end, you will have a vacuum over here. So this is the exhaust that goes to
And
the
just-
ACC unit. We call it air-cooled condenser. So we'll go out there. I will show you what it is. So basically, you run the steam through the unit, use that all energy to spin it, and provide enough, basically enough power to run the generator. It all depends on the load, how much steam you need here. But we are trying to maintain the constant speed, frequency. So that's what you have to maintain. That's what the government does. It maintains the speed of the unit.
Just
It's
keep
got to be constant.
steady speed
So the rotation,
all the time.
RPMs, they don't go up and down. You just keep the steady.
24 hours a day, 7 days a week.
365, 30 years from now.
That thing's going to get a lot of work over the next few decades.
Oh,
It is
yes.
going to be going. And I'm assuming if you had to replace that, that would just...
That would be a big
It'd be a big
event.
job.
Big disaster if you have to replace the whole thing.
So-
You'll have to do some maintenance, like every so many years you have to open up the turbine, look at the blades, look for the corrosion, for wear, any damages, but that's part of the maintenance.
Great.
That's what we do on the boilers at the power plant. They do it every year. They do overhaul of the boilers. This boiler, I guess, is scheduled to have an overhaul every year, but the turbine is could be every 5-7 years. It depends.
Has the turbine even spun once yet? For
Yes, we had it on the
for
turning
testing?
gear. We never ran the steam to it.
Oh,
We have
okay.
a turning gear so that we can rotate it.
Oh, so you can just...
Yeah. We do the soft start on the motor up there. You see that motor on the top of the turning gear?
Right up there.
And we spin the turbine. Now it's not spinning.
So it's ready to go.
It's almost
Just needs-
there.
Just a little bit of steam. All right,
Just a
great.
little steam.
And then this generator is what the power comes from here. It goes out on the power lines and all that stuff up
Yeah,
to
the
the...
switch gear distribution system goes to campus.
All up to campus, right from here.
Keeps people happy.
And warm.
Warm, that's steam.
The steam is the warm.
Steam is the warm.
The energy-
comfort.
the energy is
Power
the
for
happy.
for the iPhones and the internet.
Nice.
That's must.
And the lights.
And the lights.
And the refrigerators.
The refrigerators. Correct. So that's basically.
So it's a big room. This is a big room
This is a big
for
room.
this.
Yeah, we have a crane above, so if you have to do the maintenance, you can lift all those covers and parts. They're pretty heavy. So you have a lot of space here, so you can open up, set all those covers up here, so you don't have to move them.
Just bring it right out here,
Yeah.
do whatever needs to be done to maintain it, then you can put it right back together. Need a big space for
The
that.
actual control room, we were
We were
just
just up there.
so they can see what's happening in the turbine. And let's go down.
Let's go down! So is this when it's running, is this a gathering place for people, or is it a place that you just don't come in here unless you need to?
Oh,
Like where's the break room, so to speak, or do you have a room specifically
Break room
for
for the
that?
guys.
Hello.
We'll have a small break room over here. That's our small break room.
Hello. So they're in there chatting right now. We won't.
Most of the guys, you know, when you're at the power plant, they might be in the break room. Operators will be in the control room. Maintenance guys will be walking, doing the readings. You know.
There's always something going on.
Right. And there's
Like a
always-
ship.
Like a ship. That's like a job. You don't go to the job to sit in the break room, I guess.
No, you don't. I mean, if you are, then you should be doing another job because you're not in the right place for yourself. So listen to that out there.
There is
Facebook.
always constantly something happening.
Well, that must
I
make
guess
it.
I guess I would suggest to go to the old plant and talk to those guys. And they'll tell you what they do daily, you know.
Right, and you just gotta. Well, there's a lot to do because if it's running 24 hours a day, 7 days a week, that's a lot of wear on the material, the stuff. You just gotta make sure that it's all safe and running.
So I guess we covered the coal, water, steam. Then we generate something, you know, steam and power. Now, what do we do with that ash?
What do you do with the ash?
That's a good question.
Excellent. I'm glad you asked it. That's just a normal sound.
That's normal operation. So the ash, a lot of ash goes, some of ash goes to the bottom of the boiler when it gets collected. And some ash it gets caught in the MDC unit, it's a multi-dash cycling system. MC, yeah. And then the ash is collected, and then we send this ash to the ash tower, to the ash building, basically. And from that, I'm just simplifying the whole thing.
Please.
From that, the ash is taken to the trucks, and we haul it away off campus. I don't know exactly where it goes. To the parking? No.
Yeah, it's over by the theater.
So,
Oh, we're by the theater over there.
and some of the
Hello again.
fly ash is caught in those big back houses. This is a back house building. So it's like we have a lot of bags in those units. And so the flue gas goes through those bags, and we catch the ash on the bags, and then we send like a compressor on the bags, like a big pulse of the air. We shake those bags, and
then
that
it-
fly ash goes down to the hoppers, and we transport it to the
ash building.
Correct.
And then it gets there and
So
gets
this is
hauled
all
away.
vacuum system. It pulls that ash to the ash tower. There's a big silo up there. We can go up there if you want. I can show it to you. But basically, it's like your vacuum at home. You vacuum something, you catch everything in a bag, and then you have to clean it.
And you take it to there, and then it goes to the place where it goes
Correct.
to ashes, as they say.
Yes. but basically, I'm trying to simplify.
Yeah, no, I think that's
That's the whole
basically
idea.
how it works.
And then clean air goes out through the stack.
You still got wrappers on it. It's so exciting.
So you see that ash goes through those pipes, goes to the ash tower. That's your ash building.
That's the ash building.
We can go inside.
It's still pretty clean in there, I'm assuming.
Oh yeah. So here we have two blowers. They produce that vacuum on the ash system. So they run, they produce vacuum, and we suck that ash from the hoppers to our ash silo, which is the biggest silo.
And that goes up there.
Yeah.
So if you were to be blindfolded and then spun around, and we took you to some random location throughout the building and unblindfolded you, you'd be able to know right where you were and what was going on there.
I better know that. Yes, definitely.
Definitely.
No question about it.
All right.
Here.
So it's got a big bay. You get trucks in there. I'm assuming these trucks will come in there to unload the stuff to take it away.
So you see above us, that's your ash silo.
That is where it all will
That's
be.
a humongous ash.
It sure is.
It's a simplifying piece.
You would say
All
that's a
ash
big
goes
ash
in it.
silo.
Correct. So all the ash goes in. So it's a dry ash. It's like ash from your wood stove, basically. simply saying, but it's a coal ash. So then it goes here, and we call it the ash mixer. Because you can't dump the dry ash on the truck and drive away.
Because it would just be,
You'll see a big cloud, and by the time he gets to where he goes,
it would be all gone.
all gone. So this ash mixer, what it does, you dump the ash here, you dump some water, you mix it, you make a dough, like a mud, and then you dump it on the truck. And that's how we haul it away.
Is it all cooled down, or is it steamy?
It's not cold. It might have like 100, maybe 200 degrees temperature, I guess.
So on a nice, 20 below, 30 below day,
It's still gonna be hot.
it's a nice spectacle.
Yeah, so when we dump that water on that ash in that mixer, it creates some steam, but it's not significant, I guess.
Right. But that's an important end of the process. Like,
Right.
nothing happens without sort of
So you see that
something
chute?
left over.
You see that chute over here?
Yeah.
So the dump truck will pull in here, and the guy's gonna operate it from over here to start the process, and he will dump it, fills up the truck, and he goes away. Then he comes back, he does it again, and
Does that happen every
you
day?
will have to do
as
it
well?
daily.
It is
during
daily?
the operations. Like I don't know, you might see you can't see it from here, but I bet you there's a dump truck up there. So that building, there's another ash tower
Oh, I
behind the
see.
water treatment plant, like a dirty
Right.
building.
That's because it's been doing it for 50 years.
50 years, exactly. So that's basically what it's going to be.
So the coal's coming in every day, ash is going out every day.
So
We're energized.
We use what
and-
we want, what we can, the energy from the coal, and this is just the leftover. And ash goes, and that's
That's the end of the cycle.
the end of the cycle, I guess.
Well, for what happens here, for the generating, it's really the beginning of what happens on the rest of the campus when
I
you
guess.
turn on your tap to
For
get hot
us-
water instantly.
For us, it's the end. For them, it's the beginning, I guess. So that this whole coal cycle, you see how it goes? Mm-hmm. We bring the coal from Isabel coal mine. We dump to the Grizzly, transport to the metal separator, crushers, bucket elevator, coal silo, feeders to the boiler. We burn it, and then
Burn it,
left over
turns
is
it into the steam.
to the steam. But I'm just talking about
Yeah,
coal. Then
just the coal.
ash comes here, and it's gone. That's the cycle of the coal here. Water comes in. When it goes to the boiler, we kind of preheat it. So it runs through the economizer in the boiler, so it heats up the water a little bit. Then it goes through the feed water heater, and then past that, it goes to the boiler. We don't dump cold water to the hot boiler because we don't want to shock the boiler.
Right, it's
So
just
that's
like
the-
a fish. Like you don't want to take that fish from the pet store and dump it right in your aquarium.
Or like anybody, I guess.
Like, it's just got to get your toes a little wet first
Correct.
before you jump in.
So that's so that water goes to the boiler. We heat it up. We produce the steam. Correct. Then it goes to the turbine, and then after the turbine, when we use that all energy, 600 pounds and temperature, all that energy from the steam becomes wet at the end of the day, and it comes to this building. This is like a big radiator.
Ah,
You can look like we have 3 big fans.
whoa. Those are big fans.
Yes, so there's a lot of tubes up there. I don't think so. You want to go up there?
Sure, there's tubes.
It's like basically a radiator in your car. You take the hot water, you have a fan, you cool it down, correct?
Yeah.
But here, we have a steam that's in it. We cool it down, and the water comes out. The steam condenses.
Yes. Water wants to be liquid.
So basically, ideally, it's like a closed loop. You bring the water, you create a steam, then you condense the steam, and you bring that water back and you heat it up. It's a cycle. Make sense?
Yes. Because like with the coal, the ash is what you get after you release the energy. But with water, it's liquid and it's gas and solid all at the same time.
Put energy in it. We transfer the energy from the coal into the water. We use it up. So you see, this is your radiator. All those fins here.
Heat.
Correct. So it'll be secondary from the bottom. Goes up.
Does it get really hot up here? Like, whoo!
It's not gonna get hot here.
You come up here to like warm up on a winter day?
I wouldn't be here. There's warmer places in the building.
So how does it freeze up at the top? Like when does it?
No, it's not gonna freeze. So the water is contained. So there's no vapors, nothing. So basically you run the hot steam through it and then you run the cold air. So it's like a heat exchanger basically. So we'll be warming up that air and we'll release it to the atmosphere. So that's our waste of energy basically.
The water vapor.
That all the power plants, they do it. So you have to condense that steam. And that's basically where you use that energy because it's not used for anything. This is our cleaning system. So we're gonna hook up the water to it. Let's get like a jet so you can clean up all those tubes.
Oh, I see.
Because they will get dust to it and other stuff. So we'll plug them. If you plug them, they're not as efficient as they're supposed to.
So there's a little.
So this unit goes all the way up and down, and it will go, go east-west and up and down, and we'll clean up all the tubes. So we have one on each side. This is like a triangle-shaped radiator. But we can go on the other side if you want.
If it's just the same as this, and I think.
It's the same, exactly.
So does someone have to do that, or does the computer do that? It runs it up and down.
Somebody's gonna be here run it because you have to run the hose with the water.
Oh. That is the biggest radiator I've ever seen. Have you seen a bigger
that's true.
radiator?
No, I guess we have.
Yes!
Hey, not here.
Oh, okay. That was a roller coaster. Thanks.
You see that pipe? That's the exhaust.
So all of these things, I mean, you can't manufacture that here.
No.
That had to be brought in here from somewhere. Is it stuff from all over the world, just all over the United States?
So that's a good question. So a lot of parts, big equipment, came from like a generator came from Europe. Turbine came from Japan, for example. Boiler parts were manufactured. I think part of it was Mexico and the United States. Steel came from China. So it's a huge logistic task to get all those parts here in the right time and try to put them all together. So like a silo, for example, it came in parts and it was assembled at the yard, at the Nanana parking lot. I don't know, you've seen it in the last 3 years. They were trying to put all this together, so that's how it worked. You bring the smaller parts, you put them together, and then you try to put them inside the building. So when we were erecting the boiler building, for example, that was the way they decided to do it, erect some steel and leave the roof open so they can bring a big crane and install those silos from the top. So the sequencing was the very important, how to do the steel members and everything else. You can't just say, oh, I'm gonna build a building and then put all the equipment in later. It wouldn't fit. The same was with the steam drum. The one, remember steam drum on top of the boiler?
Yeah.
They left the opening in the roof, they brought it down.
With a big crane.
Correct, because you want to build that boiler from the bottom. Those walls, the screen walls. So the sequence was whoever did that, there was a guy here inside there. It's pretty. He did a pretty good job on that. So here, what do we have here? So this is a STG building. We're back in the building.
Steam turbine
generator
building.
So we're on the first floor. So this is a lube oil system.
Keep things
It's
running.
for the steam turbine. So it provides oil for the turbine and control oil, lube oil, and we call it emergency oil, so we can trip the valves.
Do you have to put new oil in it frequently, or is it just keep recycling the stuff that's in there from the beginning?
They will have to do some oil changes, but I don't know what the sequence on it is.
You just lift it up with a jack, you get under there, you take the filter off.
You basically just drain it and put the new oil in it, and there's filters in it.
And you got an old school little bag hanging there on a trolley.
So the oil gets hot from the turbine, so we have those heat exchangers. We cool that oil. So this is part of the turbine. It's an important piece of it.
Because that thing's going so fast, it's got to make sure that you can keep
lubrication
on
the bearings
all the time, all the
yes,
time,
correct.
all the time.
This piece is it's like we call it. It's a heat exchanger basically. So in the winter, we take some of that exhaust steam that we waste in the ACC unit up here, and we run our water through it, run glycol, and we heat up that glycol. And that glycol is part of is sent to campus to the preheating coils to the buildings. So it's a low energy steam, and glycol is up at 120 degrees, I guess, 110. But it gives us free heating to the preheating coils into the buildings. It's part of the loop that in the summer we run a chilled water to the buildings to cool the buildings. So in the summer we don't use this. You know what I'm saying?
Yeah.
We use the chilled water from the chillers down in the power plant
To keep the buildings a little
building
cooler.
cold. In the winter we don't use chillers, but we have the loop available. So we isolate the chillers and we run water through this. So we warm up the water and we send that low energy, low heat water to those preheating coils. So that will help you to preheat the air from minus 40 maybe to 20 or to...
Just add a little ambient heat to what's going on.
It's just a free energy. I mean, it's not free because you have to pay for the pump.
Right, it goes through all the... And so on campus, you often see pipes that say glycol with the arrow pointing in the way the glycol
those
is
are
flowing.
within the building. Those are different ones.
Different stuff.
Different stuff. But
so that's
but
nice. So you
like
can use-
engineering building, I think last winter ran only of that low energy heat. But
So
that
just-
will be a question for Cameron, I guess.
Yes. But it adds a little bit, use a little bit of extra heat that you've got
keeps
going
everything
on
more
down here.
efficient.
Yeah.
That's the idea behind it.
That's beautiful.
Then we have a lot of pumps, heat exchangers. It's for the auxiliary cooling. We call it ACW system. So there's a lot of water that needs to be used for cooling the system all over the power plant.
Whew.
What else we didn't see? Oh, we can go to the basement.
Oh, that sounds
the last
great.
one. But I think you'll lose your reception.
Okay, well, we'll find out. Let's put it to the test.
Okay.
Have you signed somewhere? Oh, that's you. Arlene just posted in the video. Have you signed a little place of the plant just for yourself? A little secret initials?
Me?
Yeah, you.
No.
No, of course not.
No. It's a secret. I'm not going to tell you.
Yeah, a tradition or no, it's a secret. Okay, fair enough.
Nice try.
Fair enough. The basement. Whew. So you can look up, like we could look up, and it's through the grates all the way up.
Almost.
They go all the way. That's crazy. Oh,
I don't want to. Okay, let's
all right, that's it.
excuse me.
Thank you. All right,
So we're going to the basement of the park.
the basement. All right, let's see if we can keep signal down here. Find out.
So here we have two big primer fans.
Yes.
So those are they're blowing the air to the boiler. There's two of them. So
That
since
one?
you need air to burn something, those guys, they provide the air for the boiler.
So they send them air up there so that the fire can catch, and then it can light the coal.
Simply
The
saying,
coal can
correct.
boil the water, and the water can
Burn,
start the
boil
whole
the water,
steam stuff
steam,
going.
and it's all...
It's amazing how it all like works together. You need all these.
Oh, there's a lot of vibration sensors on the motor.
We're back.
So that's where we are. And,
It's I see the most of the gauges are asleep. They're just down there. They're at zero.
yeah,
They're just waiting to wake up.
Waiting for the day one.
Day one. That's when they get to work.
And this is our emergency pump. It's a feed water pump. It's just a steam driven. So we lose power, we can run the steam and run that pump. So we don't need electricity.
So you've always got backups. I think that's an important thing.
7, you know.
And they go right to there.
Maybe we can go on the other side.
We'll just go out.
Don't worry. So here we are on this side.
There's a backflow test header right there.
Yeah, and then you have FDC connections for fire department, so they come in here, hook up. So
Hopefully they will never have to do that.
Hopefully not. So that's our utility bridge I was telling you earlier.
Yep, goes from this new building, which has no name right now, except secret names that nobody's telling anybody,
Correct.
and then the Atkinson building.
Yeah, you can walk in the bridge. It's not just piping. You can walk between two towers. So we've been here. That's the material handling. And, I guess.
This is full circle.
I guess we've done it full circle. Yeah. Anything else I can show you? I guess.
I think that's it, pretty much.
That's it. And
Well, there's no button you're going to push to start things on.
no, there's no secret one like our red one.
But is this a sort of project where when it starts in November, are you going to have a hole in your heart like when it's done? Is it going to be like,
Probably,
what do I think about now? What do I work on now?
Oh, there'll be more other projects on campus, you know, smaller, bigger. This is the biggest one I've been involved in my life, I guess. So the next project probably is going to be like, oh, this is so small, but it's still important.
Right,
know?
right.
There might be small, bigger, but they are still important for the end users, the projects.
So you have a vacation plan? Like after it goes up, you know it's running for a couple of weeks? Or...
Maybe next year. I'm not counting.
Okay.
There's always a plan, but we'll see how it all goes.
Yes, it's true. It's true.
Yeah, that's going to be something like, I guess I spent, 4 years on this project, maybe 5. So that's
it's a big time.
big commitment, I guess.
All right, well, before we go in here, to say thank you.
Hey, thank you.
Thank you very much.
It was a pleasure to have you here.
Look back at your... Oh,
Yeah,
look at that.
almost done.
Oh. Thank you for taking a couple hours to
Thank
walk
you.
around with me. I
Hey,
really, really
nice to meet
appreciate
you.
it. We'll share it. We'll make sure that video gets out there. And I look forward to seeing... We got some pictures of the groundbreaking.
It's on the 20... I don't know. If there is one, maybe there is
I
one.
don't know. Who knows when the event's set up, but we will be here
There'll
for
be
that.
something, I guess.
Balloons.
You will hear about it.
Yeah, oh yeah. We'll hear about it. Thank you very, very much.
Yeah, you have any questions, give me a call, and we invite you for the next or when it's all running.
Awesome.
Up